Now welcome everybody to this latest video on 162 Matter, and in this video we'll be going over some of the projected number topics that will appear on the 2022 AQA Higher Maths paper. Now I have included a copy of the questions in the description below, which I recommend that you download, have an attempt at before watching this video as go through the answers. So here are the list of topics that all of these questions on the mix sheet are related to, and they're all taken from the AQA supplement, which tells you which topics are going to appear on which paper for the 2022 papers. So looking at question 1, which relates to fractions, it says that we've got 1/6, 1/7, 1/8 and 1/9 are for fractions. How many of these fractions convert to a reoccurring decimal? Now there's a couple of ways in which you can do this. You're only going to get 1 mark, so you've got about a minute to do this, so hopefully you'll recognize what some of them are. But basically 3 of them are reoccurring decimals. So if you converted, now remember that when you're converting fractions, again, one way to do that is to actually convert them into decimals by using the bus stop method. And what you should find is that 1/6 is going to be 0.1666 recurring. 1/7 is 0.142857 recurring. 1/8 is 0.125 and 1/9 is 0.1 recurring. So 3 of them are recurring decimals. Then moving on to question 2, it says put these in order starting with the smallest. So again, what you want to do here is maybe convert them so that they're all in decimals. So just recognize that this is 0.333 recurring. So which is smaller? Well, it'll be minus 0.3, a third, 3.303 and 33.3. Then for question B, it says Joe thinks that the difference between minus 0.3 and 33.3 is 33. Is she correct? Well, no, she's not, because if we simply draw a number line, you can see that the difference is going to be 0.3 plus 33.3. So the actual difference is going to be 0.3 plus 33.3, which is 33.6. And there we go. So then moving on to question 3, it says that use this fact to show that, well, if 0.7 recurring is 7/9, use this fact to show that 0.07 recurring equals 7/90. Now again, a couple of ways in which you can do this. So one way is recognizing that 0.7 divided by 10 is 0.07 recurring. Then we can write this as a fraction. So I could write this as 7/9 divided by 10, which is 7/9 divided by 10/1, which is 7/9 times 1/10, which is 7/90. So again, one way of simply working this bit out. Then says using part A or otherwise convert 0.27 recurring into a fraction. Now I'm going to use the part in A. So what we've got is we've got 0.27 recurring is equal to 0.2 plus 0.07 recurring. Now we know that this from part A is 7/90, and we convert 0.2 as 2/10. Then if I have a common denominator, so I multiply this first fraction by 9, I get 18/90 plus 7/90, which equals 25/90, which simplifies to give me 5/18. Now, if I didn't want to use the part of the answer, then what I could have done is made x equals 0.27 recurring, times that by 10, and I get 2.7 recurring, times x by 100, and I get 27.7 recurring. Then using these two, I've got 100x equals 27.7 recurring, 10x equals 2.7 recurring. If I take the two numbers away, I get 90x equals 25, then x equals 25/90, which simplifies to give me 5/18. So any of those two methods would have been absolutely fine. Then moving on to question 4, it says express 0.15 recurring. So again, for this, I'm just going to use the method of using algebra. I've got x equals 0.15 recurring, times it by 10, and I get 1.5 recurring, times it by 100, I get 15.5 recurring. Then using these two, I've got 100x minus 10x equals 15.5 recurring equals 1.5 recurring. Take the numbers away, so I end up with 90x equals, and it's going to be 14. So x equals 14 over 90, which is 7 over 45, and there is my final answer. Now just be careful that if I was to use this, that if I take the two things away, try not to remember that that's 90 equals, let's say 14, because it's not, because again my top line is smaller, so I'm going to end up with minus 90 and minus 14. So another way of, rather than dealing with negatives, is just rewrite the equation so the bigger one is at the top. Then moving on to question 5, it says when a number is multiplied by 2 1/4, the answer is 3. Now what you want to try to do with these questions is not that it makes a difference, but you've got a number, which I'm just going to put a box, multiplied by 2 1/4, the answer is 3. So that means that if I just call this x, that x is going to equal 3 divided by 2 1/4. Now if you wrote it as 3 over 2 1/4, it's just recognizing that that is the same thing. Then from this, what I've got is I've got 3 divided by, now if I convert this into a mixed number, we've got 4 times 2, which is 8, plus 1 is 9, so it's 9 over 4. And then from this, I just go over, I can convert this into a fraction. So I flip the second fraction, so I've got 3 over 1, 4 over 9, and that turns to a times. And so I've got 3 times 4, which is 12, over 9, which simplifies to give me 4 and over 3, so it's 4/3, and there is my final answer. Then for question 6, it says 3/5 of a number is 162. Work out that number. Well, if 3/5 equals 162, then that means that 3 parts equals 162. So 1 part is going to equal 162 divided by 3. And if I quickly do that, remembering that this is a set of non-calculated questions. So then from this, I've got 3's into 1 goes 0, 5, 4, so it equals 54. And then 5 times 54. And again, you can do that any which way you want. So I've got 2, and then so it's 270. Then moving on to question 7, it says that 1 1/4 is an eighth. What fraction of 1 1/4 is 1/8? So for this, what I'm trying to do is 1/8 over 1 1/4. So if I convert this bottom into a mixed improper fraction, I get 1 over 8 divided by, and then it's 1 times 4, which is 4, plus 1 is 5 over 4. And this is 1/8 divided by 5 over 4, which is 1/8 times 4 over 5, which is 4 over 40, which simplifies to give me a tenth. So it's my second option. Then moving on to question 8, it says 9/10 of runners who started a marathon completed it. 1/5 of those who completed it are women. 180 women completed the marathon. How many runners started the marathon? So for this, what I need to work out is that basically 1/5 equals 180. So that then means that in terms of the total that completed, so total completed is going to be 180 times 5, which is 900. And 9/10 equals 900. So 900 divided by 10, so divided by 9 rather, times by 10, that is a 9, not a 4, because obviously 9 parts equals 900, and I want to work out what 10 parts equals. So then divided by 9, times it by 10, and you see that there are 1,000 people who competed in the marathon. Then moving on to question 9, which then looks at indices. So here we've got minus a third. or 3/4 to the power of minus third. Now, when you do the reciprocal of, now what this basically equals, it's 1 over 3/4 to the power of 3. Now, it doesn't really matter which one you do first, if you want to do the reciprocal first or the number cubing first. Now, generally speaking, when you are dealing with a negative and a fraction, a negative power and a fraction, just simply flip the fraction. So this then becomes, so if I have 3/4 minus 3, then if I flip the fraction, that then turns the power into a positive, and then just cube both numbers. So 4 cubed is 64, 3 cubed is 27. So my final answer then is 64 over 27. Or I could write the answer as 2 and 10/27 as a mixed number, but that's either way. Now, if you wanted to, you could have cubed the numbers first. So I could have had 27 over 64, and that's to the power of minus 1. And then with the negative reciprocal, or negative power, just flip the fraction and then we get the same answer. So either or which way you want to do it is fine. Then moving on to question 10, it says work out the square root of 12 1/4. So again, into an improper fraction. So what we want to do first is write this as an improper fraction. So 12 times 4 is 48, plus 1 is 49 over 4. Then you should recognize that these are both square numbers. So square root of 49 over the square root of 4, which is 7 over 2, and I'm leaving it as an improper fraction as they've told me to, so it's 7 over 2. Then for question B, it says work out the cube root of 16 as a power of 2. So what you want to do here is look at the base numbers and convert that as power of 2. So 16 is 2 to the power of 3. So then what this then becomes is the cube root of 16 equals the cube root of 2 to the power of 3, and so 2 to the power of 4 rather, not cubed, be a 4, and that should be a 4, otherwise they would have both cancelled each other out. And then remembering the rules of indices, so when you've got a fraction, the numerator is the power, the root is the denominator. So here I've got 2, the power is 4, and the root is 3, so it's 2 to the power of 4 over 3. Then moving on to question 11, it says work out the value of 81 to the power of minus a quarter. So again, what I've got is 81 to the quarter is the quart root of 81, which is 3. So then what I've then got is 3 to the power of minus 1. So then it's 1 over 3. Then for question B, and if you did write it as 0.3 recurring, as long as you've got the recurring, that should be fine, because the question doesn't specify how they want you to write your final answer. Then with question B, it says write 16 times 8 to the power of 2x as a power of 2 in terms of x. So what you want to do here is we want to have write 16 and 8 as a power of 2. Now 8, so 2 to the power of 1 is 2, 2 squared is 4, 2 cubed is 8, 2 to the power of 4 is 16. So I'm going to rewrite 16 as 2 to the power of 4. And I'm going to rewrite 8 as 2 to the power of 3. And that's the power of 2x. Then with brackets, you multiply out the powers. So I've got 2 to the power of 4 times, and then 3 times 2x is 6x. And then when you're multiplying, you add the powers. So then that then becomes 2 to the power of 4 plus 6x, which is what they want me to do. So my final answer is 2 plus 4 plus 6x, or you could write 2 to the power of 6x plus 4, or you could even go a little bit extra and factorize it. So you could have 2 and then 2 plus 3x is fine. But again, unnecessary. I would say ones I've put on the answer line will probably be the most popular answers. Then moving on to question 12, it says work out the value of 8 to the power of minus 2. So again, this is 1 over 8 squared. So it's 1 over 64, which is our fourth option. Then looking at B, this is very similar to the previous question. So what you want to notice is you want to have the base numbers the same, and you should notice that 4 and 8 are powers of 2. Can be rewritten as powers of 2. So this 4 to the power of x could be written as 2 squared to the power of x. And 8 can be written as 2 cubed, and that's to the power of 2 over 3. So here what we then want to do is then when you're multiplying is you multiply out with brackets, rather you multiply out the brackets. So that then becomes 2 to the power of 2x equals 2 to the power. Now 3 times 2/3 is just 2. So therefore from this we notice that 2x must equal 2. So 2x equals 2, and so solving that gives us a value of 1. Then with C, move that up. So we've got simplify the square root of 3 to the power 0 times 3 to the power 1 plus 3 squared. And that is a square. So let me just put that into a plus. So here what we've got is let me just rewrite it. There we go. So looking at this, well, 3 to the power of 0 is just 1 times, and then if we work this out here, well, we've got 3 plus 9, which is 12. So we've got the square root of all of that, and 1 plus 12. So 1 plus 12. 1 times 12 is 12. And then we want to write this, simplifying it. So root 12 can be written as root 4 times root 3. Root 4 is 2. Can't simplify root 3, and there is our final answer. And as you can see, it's written in the form that they want me to, so a equals 2. Then moving on to question 13. So now we move on to standard form. So with standard form, we've got a times 10 to the power of 4 plus a times 10 squared equals 24,240. And the question says work out a times 10 to the power of 4 minus a times 10 to the power 2. Now what you need to remember is that with 24,240, we want to split this up so that it's 24,240. So that's, if we add two numbers, and that's what it's going to equal. Now this is 2.4 times 10 to the power of 4, and this is 2.4 times 10 to the power of 2. So from this we know that a equals 2.4. So then from this, what we then want to do is 2.4 times 10 to the 4 minus 2.4 times 10 to the 2. So this is 24,000 minus 240. And again, if you word that out just using simple subtraction, you should get an answer of 23760. And then we want to write that in standard form. So it's 2.376 times 10 to the power of 4, and there is my final answer. And this is what the answer needs to be, not necessarily that. So let me just finish that off. And there we go. And moving on to question 14. So again, another standard form question. It says work out the value of 5.4 times 10 to the power of 5 times 2 times 10 to the power minus 2. So for this, what you want to do is multiply out the numbers first. So I've got 5.4 times 2, which is 10.8, and then I've got 10 to the power of 5 times 10 to the power of minus 2. So I add the powers, so it becomes 10 to the power of 3. Now from this, what you should notice is that this is not in correct standard form. So if I need to make this number smaller by 1 decimal place, I need to make the power bigger by 1. So the correct answer is 1.08 times 10 to the power of 4. Then moving on to question 15. So this, all we need to do is just simply convert it into normal, nice standard form. So the first answer is going to be 7 times 10. Now it's a small number, so it's going to be minus. Then we just count the number of zeros, and that's to the power of minus 7. Then with, don't know what's happened there. And then with B, we've got 3 times 10 to the power of 5 in ordinary form, so that's going to be 3. I've got no numbers after the decimal point, so 5 take away 0 is 5, so I've got 5 zeros. And then with C, I've got 4 times 8, which is 32, times, and then add the powers of 10, so I've got 10 to the power 8. Now that's not in standard form, so if I make this number smaller, I need to make the power bigger, so it's 3.2 times 10 to the power of 9. Then moving on to question 16, it says 2 times 10 to the power of 5 multiplied by x squared equals 1.8 times 10 to the power 8, and we need to solve the equation. So from this, what we've then got is if I expand the brackets out, I end up, well, if I take this over to the other side, I end up with x squared equals 1.8 times 10 to the power 8, all divided by 2 times 10 to the power of 5. Now, dividing 1.2 divided by 2 equals 0.9, and 10 to the power of 8 divided by 10 to the power of 5, I take away the powers, and that gives me 10 to the power of 3. So what I've then got is I've got x squared equals 0.9 times 10 to the power of 3. Now, with this, I need to make this number bigger, so that becomes a 9. So I'll make the power of 10 smaller, so then that then becomes that. Now that's what x squared equals. So x is going to equal the square root, or plus or minus, the square root of 9 times 10 squared. So here, if I square root the 9, I get 3. So it's going to be plus or minus 3. Square root 100 or 10 squared, I get 10. So the answer then is plus or minus 3 times 10. So the answer then is going to be minus 30 or positive 30. Then moving on to question 17. So this is where we then start moving on to surds. And the question is asking me to show that 2 root 6 over root 5 minus root 3 over root 10 can be written in this form of c root d over 10, where c and d are integers. Now there's a couple of ways in which you can do this, and it's entirely up to you which way you do. So let me just split the answers up. So to start off with, let's just write down the question, and I'll explain what I'm doing. Let me change colour of pen as well. So for this, if I multiply to try and get a common denominator, so I'm going to multiply this by root 10 over root 10, and this fraction by root 5 over root 5. So what I end up with is 2 root 60 over root 10, or over root 50 rather, minus root 15 over root 50. And now I've got a common denominator, so I've got 2 root 60 minus root 15 over root 50. Then from this, I should notice that root 60 is root 4 times root 15, which is 2 root 15. And so that times, so then 2 root 60 is going to equal 4 root 15. So then I've got 4 root 15 minus root 15 all over root 50, which equals 3 root 15 over root 50. And then from this, I can then simplify it further. So root 50 is basically root 25 times root 2. So it's 5 root 2. So then this then becomes 3 root 15 over 5 root 2. If I multiply and try and rationalise the denominator, I end up with 3 over root 30 over 5 times root 4, which is 3 root 30 over 10. And that then gives me my final answer. So this is my final answer. Now, a quicker way of doing it, but again, probably not very popular in terms of what students would do, is if I start with this question here. Now, let's say I'm going to rationalize the denominator right from the offset. So I'm going to multiply this first fraction by root 5 over root 5. And I'm going to multiply this fraction, the second fraction, by root 10 over root 10. And what that then does is it gives me 2 root 30 over 5 minus, and then this is going to be root 30 over 10. Then you can see that I've already rationalized the denominator, so I've just got to then get a common denominator. So I multiply this by 2 over 2. So that becomes 4 root 30 over 10 minus root 30 over 10, which then becomes 3 root 30 over 10. And there I've got my final answer, because it's in this form where c equals 3 and d equals 30. So 2 ways in which you can do it, and either one is going to be absolutely fine. Then with question 18, it says write root 12 plus 15 over root 3 in the form of a root b. So we just rationalize the denominator here. So here it's recognizing that root 12 is root 4 times root 3, which is 2 root 3. And so let's just substituting that in. So if I swap root 12 for 2 root 3, what does that look like? Well, it looks like 2 root 3 plus 15 over root 3. So then if I then multiply this fraction by root 3 over root 3, I get 2 root 3 plus, and then it's going to be 15 root 3 over 3. And then simplifying this second fraction, the 15 and the 3 cancel out, leaving with 5. So I end up with 2 root 3 plus 5 root 3, and that leaves me with 7 root 3. And there is my final answer. Then moving on to question 19, again, just with some surd manipulation. So here I've got root 2 to the power of 4. So that's root 2 times root 2 times root 2 times root 2. Well, root 2 times root 2 is root 4. Root 2 times root 2 is root 4. That then becomes root 16. And root 16 is 4. Now, it's not plus or minus because I've got a positive power. So that's going to be as it is. Then with question B, it's root 2 plus 3 squared. So let me just emphasize that that is a plus. Now, it's recognizing that this is a double bracket question. So I've got root 2 plus 3. Root 2 plus 3. Then root 2 times root 2 is root 4, plus 3 root 2, plus 3 root 2, plus 9. Root 4 is 2, so I got, and then root 3 plus 3 root 2 plus root 2 is 6 root 2 plus 9. And then combining those two numbers, we get 11 plus 6 root 2. And there is my final answer. Then moving on to question 20. The question is asking us to rationalise the denominator and simplify. So to rationalise, I multiply both the top and the bottom by the denominator. So here I've got 16 root 2 over root 4, which is 16 root 2 over 2. And then 16 and the 2 cancel out, leaving me with 8. So the answer then is 8 root 2. And then moving on to our last question, again, very similar to the previous question, recognizing that this is a double bracket question. So I've got 5 minus root 3 and then 5 minus root 3. So that then becomes 25 minus 5 root 3 minus 5 root 3 plus root 9. And that's 25 minus 10 root 3 plus 3. And then adding those two numbers up, we end up with 28 minus 10 root 3. Now, there are no grades for completing these set of questions, as they're just a small collection of questions taken from the revision list. But if you are wanting the actual mark scheme to these questions, so if you did bit parts of the answers as marked here and you want to see whether you got the method marks, then they are included in the downloadable document that's in the description below, which includes all of these questions.